long time, people had an expectation to have something like planned downtime, to have something like maintenance windows during an application. With the web today, it's just not anymore the case. Everybody expects it to be online 24 hours a day, even if you're German customer and a German company and only work within Germany. There's still some people up at night at 3 a.m. And by the way, I'm totally different topic, but I learned a great discussion. And if you want to know it, come up to me and I will give you the link on how to achieve 24/7 uptime without having 24/7 machines running. And that's an interesting talk, but it's a different topic. And it goes to the social factor of users. So even though all the time all the users are online, every individual user, interestingly enough, has at least 1 hour of a day where he is never online. And this might differ for a developer that gets up at 6 a.m. This doesn't exist, I know. Unless he's doing yoga in the morning. Anyway, so the next thing people tend to expect is a wide variety of features. So they want to have all things from your website. It's not like all the static stuff we had in the 90s anymore. So features, and what comes with that, and what's essentially the business model of many of the startups here in Berlin is customization. So it has to be personal, it has to get to what you're interested in, and in many cases it's customization, but in the end, what's most important for most web application developer is how to serve the right ads to the right people, right? So, because that's where many of you make your money. Okay, so it needs to be personalized, and how do we do that? So what I did here is kind of create a rule book which says, okay, what do you need to do for your application to fulfill all these promises? And the first of all, kind of seems obvious, is service or web requests. So every request that comes in, that comes to your application, needs to be serviced by your application. And if we take a deeper look at how an application works, the first thing, interestingly enough, that happens when somebody wants to get to your application has nothing to do with your application at all. It's DNS name resolution, right? Because, the dream of every sysadmin is an application that's up and running without users, because nobody can destroy anything then, right? Unfortunately, it's not so good if you need to make any money from your application, so it's only for the enterprise people, no users, running application, great. I worked with enterprises a lot, so. Okay, so what do we need to do? First thing is we need to have the DNS requests mapped to an IP address or a CNAME and an IP address and so on and so forth. So make sure that your requests get to the front door of your application and the application sees it at all. So because if your DNS is not online, well, you can't do a lot with your users. So what do we need to do? First thing, and this is the talk where I talk about services, so what Nikolai talked about this morning and what Thomas added to. So what services can you use to avoid not having DNS resolution work? So we have a DNS service called Route 53, and for most people, DNS is kind of boring. So when I created my own domain for my private email and some other stuff, I tend to do this myself. I got to a domain provider, paid my €7.14 per year, and then got my DNS entries. And that's fine for something private, but if you want to do it professionally, it gets more interesting. And first of all, you need a DNS service that's 100% available. And it's an interesting thing, because where do you have a service on the internet that has an SLA of 100%? Every other service you have, it's about the number of nines you get. So you get 3 nines, you get 4 nines, you get 11 nines. But still, it's nines, it's not 100%. So this is the only service also by Amazon, which we say we have 100% SLA. But there's some really interesting features with it. Because DNS is not only an issue about uptime, about serving your requests. DNS also has the interesting feature that it's the trust for your application. There are several attacks in the past where somebody get hold of a DNS registration of a domain and then just put up the stuff somewhere else. So it doesn't go, it's still www.yourapplication.de, but then it goes to some interesting third-party software distributing site, which is probably not the software you want to distribute from your site. So integration with security, integration with where can people do what with my DNS server is really important here in this case. So integration with, and as always, I mean, the bad thing about the way we do security today is that each and every system tends to have its own login, it tends to have its own integration with some kind of security measures. And the good thing here is that it integrates at least with the Amazon security measures. So we have a system called IAM, Identity and Access Management, where you can do interesting things. So for instance, you can say, okay, this instance, this EC2 instance has access to that database, has access to that storage piece and so on and so forth. So by the instance and not by an account or something. And the DNS service also integrates with that, so it's still a programmable resource. And that's something new. People are used to the fact that they enter stuff manually in a DNS service, but here it's a programmable resource like everything else. Okay, so now we can service our DNS request. Next thing is we have the application, and the IP address is resolved. We get to the application, so we need to service that. And then it goes to the web front-end servers and to the load balancer. And that's the next thing. First of all, yes, we do have great data centers and so on. Always assume everything that can break does break. So yes, each of our instances is commodity-based, but still good instance. It can break anytime. Anytime you can lose your machine. And each of our availability zones, and always assume an availability zone like a physical data center. It's not necessarily a physical data center. One availability zone can consist of multiple physical data centers, but always assume it has the properties of a physical data center. So separate power, separate network, separate cooling, separate seismic zones for the US and Japan, especially important. Separate flooding zones. Everybody understands that, unfortunately. So, and like every property, a physical data center, or in this case an availability zone, can break down. And unfortunately, it did happen in the past. And you all read about that. So make sure that when the next time it happens, I hope it doesn't, but it may, next time it happens, you're not affected by distributing your stuff across multiple availability zones. You don't have an available architecture unless you have everything that you need in at least 2 availability zones. The good thing about the availability zone concept compared to other data center concepts from other vendors is that all of them are in the same region. So we heard the talk before about security, about privacy, about EU laws, and so on. And the good thing is that in every region we have, and we have 8 worldwide, 3 in the US, 1 in Europe, 1 in Japan, 1 in Singapore, 1 in Australia, 1 in South America, and something for the US government, which doesn't need to be of interest to you, which is not our EU data center. So the good thing, all of these regions have at least 2 availability zones. So you can have all your data in the EU, so in Ireland in this case, and still have a highly available architecture. And in Ireland, we have 3 availability zones. In US East, we have 5, and in some smaller regions like South America, we do have 2. And so always make sure to be in at least 2 availability zones. And if you want to protect yourself from large-scale stuff, so the meteor going to Ireland, or, I mean, it sounds crazy that the whole of Ireland goes down from a network perspective, right? And it probably is. Did you read what happened to New Zealand a few years ago? So that the whole central area of New Zealand was without power for more than 100 days. True. Developed country. I don't know which, anybody remember which year this was? It was by early 2000s. So, yes, it's highly improbable that this happens, but if you really want to be 100% sure, go to multiple regions. In most cases, customers go to multiple regions for different purposes. So if you serve customers here in Europe and in the US, so if you're a typical web-only startup that really wants to go worldwide, it makes a lot of sense to duplicate the exact same architecture with the exact same script, so like Thomas said before, with the SHEP receipts and so on, in Japan, in the US, in South America. The good thing about it is you can really use the exact same scripts, with the only thing you need to exchange is region code. And that's great, because if you realize that you created, let's say, the latest and greatest cat video animation service, and then, to your own surprise, realize that this is very popular in Japan, which kind of self-fulfilling prophecy, right? And then you really want to have IT infrastructure to serve your Japanese customers better. It's really hard to do, to go to a hosting provider in Japan and rent servers there, right? But with AWS, you have the advantage of really doing the same thing here. So, great, multiple regions. Multiple web servers, distributed, great. And then we have our typical problem, which is the database. Okay, because I'm an old-time database guy. I did all the relational stuff, and yes, I would want to. I would have an idea why the transaction then took 2 minutes, because there's some blocking happening. And anyway,
next time.
You can. So anyway. Problem with databases is they, especially relational databases, and that's why Nikolai was against relational databases, they tend to be very unhappy about scaling out and on distributing. So what we did for you is create a service called Relational Database Service, which is a managed database. First of all, this makes developers happy. Let me tell you a little story about this. You all know the Dilbert comic, right? The author of the Dilbert comic, Scott Adams, wrote a book aimed at enterprise people. And one of the chapters in the book was about how do I make myself irreplaceable at my company? With the purpose of not doing a lot of work, but still being there without being fired. And his idea about this was, okay, you need to do something which is always needed and is so boring that most people would rather shoot themselves than do it. And his examples were tax law and database administration. So you see how much developers love database administration. And that's why we created a managed service for you, which has the great advantage, at least as long as you're using MySQL or Oracle, that we automatically do for you the distribution across multiple availability zones. There's a feature called multi-AZ, which essentially creates a synchronous mirror of your database in a separate availability zone, which gives you three things in one place. First of all, if the availability zone goes down, you still have your database. Second of all, if your database server itself goes down, which is way more likely than the whole availability zone going down, you still have your database. And third of all, If you want to scale up or down your database, because scaling out with a relational database is not easy to do, but scaling up and down with bigger or smaller instances is easier to do. And you can do this with RDS and say, I want to have a bigger instance now during the day and a smaller instance to save money at night. What happens if you have multi-AZ? It flips over the database, so it's offline for a few seconds, 20, 30, 40 seconds, I think. Did you ever measure that? Something around that number. Then your database is online. Then it creates the bigger instance in point 1 and flips it back again, so you have your database scale up and down with a small window of downtime. It's still a window of downtime, but it's in the high number of seconds area and not in the 20 minutes area, which you usually would have. Okay, great. So we have served all web requests. Great. Next thing, performance. Service your request as fast as possible. And then we get back to our DNS service. Because, again, there's a lot happening before the request ever goes to the application. And the DNS service can do something about it if you're multi-region. If you're not, well, it just resolves things and that's it. And yes, the DNS service is distributed worldwide, so we have currently 30 locations worldwide to do this. But it can also do something if you're multi-region to measure how's the latency between your user and the region. And then route the user to the appropriate location. This kind of sounds obvious. If you're in Germany, probably Ireland is the fastest region for you. And if you're in the US, probably one of the US regions is the fastest region. But then, especially in Berlin, we have some startups which are focused on third world countries. And if you're in India, then it gets interesting. What's the fastest region? The interesting thing is it really depends on your ISP. You can have being here in Mumbai in one building, and the next region is Ireland from a performance point. And then you can have somebody across the street with a different ISP, and the fastest region is Singapore. That's the specialty about India. But if you're Middle America or all the other countries, it's kind of similar, and DNS service gives you that. So next thing is content delivery network. Content delivery, what's a content delivery network? It's essentially a cache of your data nearer to the user. So your servers are sitting in Ireland. Your users are sitting here in Berlin. So what the content delivery network essentially does is somebody is getting to your page, and the page has lots of static elements. Pictures, videos, CSS files, JavaScript files, and so on and so forth. And maybe some static HTML too. So first user gets there, gets the call from Ireland, it downloads to a content delivery network location, in this case probably one of the locations at Frankfurt, and it's serviced. Next user comes, gets the request, gets the static cached content from the Frankfurt location, it never gets to your server. So it's faster for the user. This also works for dynamic content, up to a point. Of course, you don't want to have your highly dynamic PHP, no, we're at the Ruby conference, so your highly dynamic Ruby site here cached for an hour. Because then it takes away a little bit of the dynamicity, right? But it's still worthwhile to cache, and we can do all of that with a single CNAME, so with a single entry. So the obvious advantage of a content delivery network like CloudFront is that the latency for your user gets smaller, and so things are getting faster. The not so obvious advantage is it takes away load from your servers, because everything that's cached to the content delivery network is not answered by your servers. I mean, hopefully, you don't store static content like images and videos and so on your web servers, because that's nonsense. We do have a storage service for that that can do all the delivery. So it's not the load of your web service. But if you also do take the load of your web servers and cache them for a few seconds or something, if it works for your application, It still can take a lot of stuff from your web servers. And this is two effects. First effect, better performance. Second effect, less number of machines, so less money to pay for. Okay, caching. We talked about that. Again, for many of the services I tell you about, you will say, hey, there's an open source product which is great, which is working fine. Why would I want to need to use a service like Elasticache? Why do I just not install memcached on a few set of servers? Simple answer, because then you need to have somebody that maintains that. If you ever set up a cluster of memcached for a few number of servers, well, it's not that hard to do. But at least you have to do it, you have to maintain it, and so on. And this applies to all the services. And in most cases, also more expensive to use the EC2 instances than just use the servers anyway. So what's Elasticache? It's a memcached compatible caching service. So by caching your page, by caching your database access and all of that stuff, you get better performance. It's just that easy. Okay. And we go back to the database. Because that's still the latency thing. So what happens, I told us before, relational databases were intended for single machines. And you always scaled relational database by scaling up machines. There are a few implementations like Oracle RAG or IBM PureScale which do distribute relational databases across multiple machines. These implementations have two big disadvantages. First disadvantage, they are highly complex and usually require special hardware, like a SAN or something. And the second disadvantage, they only scale up to a single-digit number of machines. So you can't have a 20-node rack cluster performing. So what people did with relational databases, especially with MySQL and something, they did something similar to what they call sharding. What's sharding? It's taking one big database and making lots of smaller databases out of that. Trouble with sharding is, first of all, it's a lot of maintenance. And second problem is you can't shard everything. So it doesn't scale with the number of machines. And the third thing is you lose all the advantages of a relational database. Because forget about real transactions if you really do sharding. Because then you still have to synchronize all these machines. So it doesn't make a lot of sense. You can do it, but the management problems just grow if you use relational for this latency. So I wouldn't tell you about this if we didn't have a solution. That's a good thing. And we were already talking about this before with DynamoDB. So what is DynamoDB? Is this recorded? Okay, then. I was about to say it's something totally boring key value store, but I don't because it is recorded. So what DynamoDB is a typical NoSQL database. So you have a key, what we call a hash key. You may have a second key, what we call a range key. So imagine hash key is customer ID, range key is date of order or something. And then you have an arbitrary number of properties, columns, attributes, whatever you want to call it, which have the type of binary, integer, string, or set of binary, set of string, set of integer. And that's all. You write these, you read these, that's it. Every relational database guy would say, and what about this feature, and what about that feature, and what? No, we don't have it. But the good thing about it is that the whole architecture is built around scaling. So we can maintain single-digit latency for writing data and reading data for any amount of data. That's the interesting stuff. We do have customers which do more than 200,000 writes per second. And similar number of reads. And we still maintain the performance. How do we do that? I mean, it's not magic what we're doing here. We just distribute the stuff across as many machines as you want. By the way, not as you want. You just say, I want to have 50,000 write operations per second. And then we calculate how much do we need to distribute your stuff so we get to the 50,000 write operations per second. It's stored on SSDs. And it's optimized for this distribution of data. Okay, kind of boring. What does this give you? It gives you the ability to handle all kinds of spiky workloads. I have a very interesting customer for DynamoDB because it sounds so old school and so not techy that I never thought that they would use it. That's the Royal Opera House of London. Opera House, physical house. Do they need to scale? Most of the time, no. Because I don't know how many seats they have, like 2,000 or something. They need to sell them out once or twice a day. Doesn't sound like a lot of performance you need. Trouble is, they have some world stars. And yes, there are world stars in Opera. And when the tickets for the next quarter go on sale, they have sometimes more than 1,000 times the number of requests for tickets than they have tickets for these stars. And all of this happens within a 10-minute interval around the tickets going on sale. Because everybody knows if I come an hour later, these are gone. So they need to scale up their database and their performance 4 times a year for about 10 minutes. That's what they can do here. Okay. So that brings us to handle requests at any scale. Okay. First of all, cloud architecture, and we heard a lot about this today, mostly is talking about scaling out. So you can have as many of your instances as you want. You can have 3 instances, you can have 1,000. But since there is old-time software, since there are special requirements, and since there are still relational databases, scaling up sometimes does make sense. Because yes, we start with the micro instance, which costs you 2 cents per hour. But you can also have an instance which has 240 gigs of RAM. So if you're really doing something RAM intensive, like calculations which don't scale out, if anybody's into mechanical engineering or something, it's really easier to do this within one machine because the equations there don't scale too well across multiple machines. Or if you want to run an in-memory database like SAP HANA, or if you need to have lots of local storage because you need very fast access to your storage, and you can have that. We do have instance types with 24 2 terabyte local physical disks. Okay, so scaling up and down is possible, and don't forget you don't have to keep an instance type forever. So you can say, okay, I'm only having heavy usage during the evening hours because I'm consumer-oriented, and maybe during Saturday, and all the rest of the time I need smaller instances. So that's good. Next thing is scaling out. So this brings us more to typical cloud architecture. So what scaling out mean? You have one type of instances, and you use more or less of them anytime. And since you pay by the hour, you can say, okay, 1 hour I have 3 instances, next hour I have 50, and next hour I have 1. 2. We do want to have high availability. Okay, but how do you do this? We have our load balancers, so everything's nicely distributed across stuff. That's fine. But we do have a service which does the scaling out, so adding machines and removing machines. The removing part is the interesting part because this saves your money automatically. We call this auto-scaling. It's one of the less known features of Amazon Web Service because it doesn't appear in the console. It's one of the features which is only available through API and command line and not through the console. So what can you do with auto-scaling? You essentially can do 4 things. One is manually. So you can just issue a command and say, please add 4 of my web servers from the web server template. You have to give it a template. which we call AMI, so Amazon Machine Image, please add 4 of these web servers to my phone. And you can do this whenever you know that something's happening. My typical example is financial calculations, end-of-month calculations. So if you're anything doing like this, which has a fixed point in time where you need additional provision capacity, do it that way. By schedule automatically. So if you're in the consumer business and you know in the evening hours I need more capacity than during daytime, or if you do a marketing thing and hope that more people are going to use your servers after the marketing campaign you do it by schedule, adding and removing machines. Where it gets interesting is by policy. So what you can say is, okay, I want to add more instances whenever the average CPU usage of my web front-end servers is above 60% for more than 10 minutes. Something like this. And then again, I want to remove instances when the average CPU usage of my instances is below 30% for the last 30 minutes maybe, because you pay by the hour, you don't want to provision and deprovision instances more than once an hour, because then you pay twice. Okay. You can have all the metrics that are available to you in CloudWatch, which is I/O, which is network, which is CPU, which is not memory. We can't measure memory. Why? Because we can't log into your instances. We can't log into your instances. We don't have access to anything inside your instance. So that's why we can't do CPU, memory. Other people that are agent-based, this is not agent-based, can do that. We don't. And you can also program this. So if you say, I have some piece of code, and the latency between the beginning of this code and the end of this code shouldn't be more than X, you can bubble up this number to CloudWatch, to the measurement system, and then do your scheduling based on that. And finally, it does auto-rebalancing. So if you're distributed across multiple availability zones, it automatically helps you in rebalancing your stuff so it's available on all availability zones. Because if you have 10 instances, and out of this 10 instances, 9 run in one availability zone and 1 runs in the other availability zone, you're not really high available, right? Because if the one with the 9 goes down, you're still probably not going to serve any web requests at all. Okay, performance. Handle requests at any scale. Yes, there are uses of EBS, of Elastic Blob Store, and quite a lot of these. For instance, relational databases. Okay, so why? No, let's say different. For a long time, the big problem with persistent storage in cloud services was the performance. Because how does persistent storage in a cloud service work? It's network-attached storage. So you have one rack of machines which run your application, and then you have another rack of machines which has the storage, and then there's some network connectivity in between. And as everybody that ever did hardware design can imagine, that's not the fastest way of doing access to disks, right? So this was an issue. So we worked on that, and what came out is provisioned IOPS. So now you can say, on an average EBS volume, you get about 100 to 150 I/O operations per second, which is not a lot, which is like a year 2000 bit disk. With EBS, you can say, I want to have a provision capacity of I/O operations per second. And mostly this is for relational databases. But there are also other use cases for that. Up to 4,000 per volume. And then you can also stripe. So you can use your Linux volume manager and do striping across multiple of these. So you can even get higher performance. So while latency to your storage is still an issue, doing lots of operations against the storage is not anymore with provisioned IOPS. So you can, as long as you're parallelized, so not have a serial disk request queue, if you have a parallel one, you can get a pretty good throughput of your disks. Or, again, you use DynamoDB. There you just say provision the throughput, provision the write operations per second, provision the read operations per second. That's it. Okay, because of time, I won't go into the customer examples. Simplify architecture with services. And thank you, Thomas, for talking about this before. And I do it again. If you worked in enterprise IT like I did before, this is very optimistic. So doing 70% of maintenance and keeping the system running, doing 30% of innovation for business. I haven't seen lots of enterprise IT departments that can have 30% of interesting new stuff. It's even worse in most cases. Anyway, let's stick with that number. But what's the problem? Managing all this stuff, it just takes time. So with AWS, with not having to manage your machines, not having to manage your storage, not having to manage your networking, it gets better. But still, if you run anything on EC2, on machines, and install everything yourself, even if though it's automated and so on, it's still a lot of work. So what we did is create lots of value-added services that take away the load. I was talking about RDS and relational stuff and not having to shoot yourself for managing a database. I was talking about DynamoDB, but there are more. Queuing. Queuing is something that, again, is useful for next to every application because you probably have something like web front-end servers, and then you have batch workers somewhere that do all the heavy, long time taking stuff like video transcoding, like doing calculations, like calculating stuff for ad serving, and so on and so forth. So queuing service is very useful. One thing that's missing from the slide, and I need to correct it, is if you take a look at the queuing service, SQS, you may miss some features which you would expect from a queuing service. The reason for this is that, to be honest, you always need to take SQS and SNS, the notification service, as one service. They are two different servers, but you only get all the features that you expect from a queuing service if you use both. Because fanning out, like here, you don't do this with a queuing service because there is no fan-out feature in the queuing service. But you can easily do it with SNS integrated. Workflow. If you have many different processes, many different applications that you need to orchestrate, workflow service may help you. Cloud search. So the ability to do a search engine. It's a great feature. Currently, it only has one drawback. It's only English. So it works great if you're searching English content, but unfortunately, no support for German yet. EMR, Hadoop. Everybody's doing Hadoop on Amazon Web Services, but EMR gives you a managed Hadoop implementation. So again, you don't need to know how to build a Hadoop cluster. You don't need to know how to shuffle around things if one server breaks down, if one disk breaks down, and so on and so forth. These are many advantages, but the biggest advantage of EMR is the ability to use spot instances. And I will talk about spot instances later, so let's add that. So, okay. Automate management. Yeah, exactly. We were talking about that. So we heard about servers as software, or what I would say, servers as a programmable resource. So we do have APIs for next to every interesting programming language in the world. So we do have .NET, PHP, Ruby, Python. I always use the Python command line and not the command line tools because I find it more intuitive to use Python and Boto than to use all the command line tools. And Python has a nice interactive console. So always think about programming all your resources and not about clicking and pointing at the console. And then we have management tools. We talked about OpsWorks, so the environment that uses Chef to deploy the servers. But if you want to start with OpsWorks, you don't need to know Chef. So it's an easy start. You can click all the stuff together, and there are pre-generated Chef recipes for what you want to do. And later on, you can start changing these recipes and adding stuff to it and something. Another interesting thing about OpsWorks is the development team is here in Berlin, which I find great to have these guys around. CloudFormation has does something similar, but has a totally different approach of doing things. Because for all your application, you're writing exactly one thing, which is a JSON file. So all the stack with everything you have in there is one big JSON file, which scares a lot of people, for good reason, but it's very powerful because it doesn't leave any flexibility and any kind of interpretation. It's just that you can check this into Git or whatever your source control system is, compare it, match it, and auto-create it with JSON. One thing is, don't try to start this from scratch. Always use example and start from there because it's just too hard to do if you really want to do it manually. And Beanstalk, finally, is kind of a platform as a service version, so it's intended for the developer that wants to deploy directly from Eclipse or from Visual Studio if you're doing Windows or all that stuff. So it's really, you upload the package and all the rest, all the configuration, including auto-scaling and something like this is done for you. Bootstrapping. So we were talking about this before. Whenever an instance starts, make sure the instance has a place to go to find out who she is. So some kind of central configuration point to know stuff from. I talked about autoscaling, I talked about CloudWatch, so that's the eventing system that tells you about the performance of your stuff. And the good thing about CloudWatch is that you can have something called an alarm, and an alarm is more intended for the administrator to see what's happening, but an alarm can again start code and do something interesting with the alarm and do some mitigation of errors and something like that. We heard about Chaos Monkey, so the Netflix tool that randomly goes around and turns off services to check if the developers are developing correctly. Because after all, I said that everything can fail. For testing, it doesn't fail often enough by itself. So you really need to do something that you can test all the failure cases. And finally, leverage unique cloud properties. Leverage the fact that you can have all the different instances types. Leverage the fact that you can have different pricing models. No developer likes to think about pricing and about money, unless he's founder. But it's really interesting. Spot instances can get you up to 80% less money for the same instance type. You place a bid and say, I want to pay only 25% of the price for this instance. And as soon as the spot price goes below that, you get your instance. Trouble is, as soon as the spot price goes up again, we take away your instance. So it's great for a batch worker. It's interesting for the architect because he really needs to deal with the fact that the instance can go away anytime. But it can save you a lot of money. EMR, I was talking about this, integrates great with spot instances, cluster compute instance. So if you want to have something like mechanical engineering that needs low latency networking in between multiple instances, do that with cluster compute instances because they have a dedicated 10 gig Ethernet interface between all the instances in a so-called placement group. And that's it. And before I get thrown out of the stage, I got all the warnings from you, Thomas. Okay, so what did we achieve? We achieved performance by having elastic capacity. We achieved by having availability zones, having redundant databases. We achieved the always on. We got the features by automatic operations, so because we took away the burden from the developer to manage the stuff. And we got all the analytics, big data to serve better ads to users, which we call personalization, right? Okay, that's it. If you want to test, we have a free tier that you can test. And the only word you need to keep in mind is AWS Aktuell. Because this is Facebook, this is webinars, this is SlideShare, this is with an underscore Twitter, and so on and so forth. And if you can't remember this, write me an email, skrause@amazon.de. Thank you.